8:1. Now, if you remember, throughout the year, I've always been talking about that. I say, okay, well, this chapter we're talking about triangles, and then this chapter we're talking about this on triangles, and then we've actually dealt with right triangles before. But if you remember, I've actually said that we're going to have a whole entire chapter just on what? Right triangles, okay? And that's what we're going to do right now. So this chapter right here is just about right triangles. The whole entire chapter is just about a right triangle, okay? One full chapter. Isn't that crazy? So the first thing we're going to do, now I'm not gonna go through a big explanation of this. It's in the book if you're really interested. It's in the book, and I bet you anything. I haven't looked yet, but if you go to Khan Academy, he might actually do a reasoning behind this stuff. I'm just going to show you the little formula that they use, the little proportion, and show you how to use it. That's really all I'm going to do. Okay, I'm not going to show you where it came from. I'll give you a general idea of where it came from. I'm not just going to go into the specifics, though. All right, and for the most part, you probably will be happy about that, that you just learned how to use the thing. But the first thing we're going to talk about is this thing called a geometric mean. Geometric, write that down. And I'm going to refer to this word quite a bit. All right, so this is not the first and last time that you'll hear this. This is a pretty important thing. It's very, very helpful, the geometric mean. Now, when you think of the word mean, I'm not talking nice mean, you know what I mean? Like, you know, there's a lot of different meanings. So there you go, there's the word mean, right? What does it mean? Or somebody's really mean to you? Or if you talk in math, though, when you talk about a mean, what are you talking about? I'm talking about the average. This is kind of, it's not exactly an average, it's kind of an average, not really, a little bit, I don't know. It's hard to say. But let me just show you how to do the geometric mean. And I think if you know how to do it, it's very practical, all right, for solving for missing parts of a right triangle. So here we go. Here's the geometric mean. First of all, it's a proportion. So it's a fraction set equal to another fraction. That's what the geometric mean is. Now, what I'm going to do is I'm going to put a variable right here, x, and I'm going to put the same exact variable diagonally to it. Okay, just like this. Now, I could have put it on the other two spots if I wanted to. It doesn't make any difference. Everybody watching? There's a lot going on. What's going on? Okay, so this is the geometric mean. X is the geometric mean. So there's going to be questions on there that says, find the geometric mean between these two other numbers. Well, what am I finding? I'm solving for x. I'm trying to find what x is equal to. That is the geometric mean. Whether or not we really have a good understanding right now of what that means to find the geometric mean, it's fine. But you'll see how to use it in a second. Let's get to a different color. Now, the question is going to say, find the geometric mean between two numbers. So I need two other numbers. I need a number here and a number here. And so we'll just call that A and B for right now, just to be real general. Okay, we'll stick some numbers in a second. But right now, that's our geometric mean. All right, so know how to set it up. So if I say, find the geometric mean, what are you solving for here if I say, find the geometric mean?
X over A.
Solving. No, what are you solving for?
X.
Solving for x. Okay, you're solving for x. Does that make sense? Okay, because I said x was geometric mean. So if I said find the geometric mean, you're solving for x. Now the a and the b represent a couple numbers. Okay, they'll throw a couple numbers in there at you. Let's just do a real easy example. Question will say something like this. It'll say find the geometric, I'll just shorten this, the geometric mean between, okay, that's not black and white, that's between, and then they'll give you two numbers. I don't know, let's say 3 and 9. Okay, say 3 and 9. This is really not an arithmetic mean. You know what that means? Like arithmetic. Okay, arithmetic. It's not just, you know, you add them up, divide by 2. That's not what we're finding. It's a different thing. So if I wanted to find the geometric mean between 3 and 9, this is what I would do. Watch how I set this up. I set up a proportion. So this is the first thing I do. I put two fraction bars, put an equal in between. Now it says find the geometric mean. What am I going to make as the geometric mean? X. Right. So where do I put it? I put it diagonally. One here and one here. If you wanted to, you could put it over here on these two. It doesn't make any difference. I don't know. I just always put it here and here. All right? Chris, you getting all this? Okay. So I put the geometric mean here and here. Now it says between 3 and 9. Where do you think I'm going to put 3 and 9? In the other spots, right? So put 3 here and 9 here. And it actually doesn't matter whether you put the 9 on top or on the bottom, or the 3 on the bottom or the top. It doesn't make any difference. Because what are you going to do with these, do you think, to solve for x? You're going to cross multiply, exactly right. So let's go ahead and do that. And let's cross multiply. All right, so x times x squared. And then, watch what I'm going to do here. I'm not actually going to multiply them together to get 27. I'll show you why in a second. It's 3 times 9 or 9 times 3. What I want you to start doing, I want you to start learning to simplify the radicals. All right? Hold on a second. All right, so watch what I do. The reason I don't multiply these together is because I'm going to take the square root of this, take the square root of this, and I'm going to simplify. Remember the rule? I can take each one individually. I'll show you the step. You might be able to do this in your head, but I'll just show you the step. You should have learned this in Algebra 1. Some people do, some people don't. Okay, so I'm just going to show it to you right now. Watch, this is the square root of 9, right, times what? The square root of 3. Everybody see that? It's not too hard to see, is it? So yeah, so what's the square root of 9?
3.
It's just plain old 3, right? It's a whole number 3. Square root of 3, I can't do anything else with it, so I just leave it square root of 3. And that's how you really should write your answer right there. Okay? You understand why I didn't go to 27? Because if I went to 27, guess what I would do anyway? I'd probably split it up to 9 and 3 anyway, so why not just keep it 9 and 3? Would you agree with that? Okay. Don't write it as a decimal. All right, don't plug it into a calculator and get a decimal. Let's write it. This is an exact answer. A decimal is not an exact answer. It's an approximation, isn't it? So I want an exact answer. That would be your exact answer in simplest form. We good with that? And that's basically it for geometric mean. If it says find the geometric mean, you just stick one of the numbers here, one of them here, cross multiply, and then you just work it out and simplify your answer. It's very, very simple. What's that? No. That's part of it. This is a tool that we're going to use to solve some missing sides of a triangle. Yes. Like inside of here? No, because these are actually, you'll see in a second, these actually represent the lengths of a side of a triangle or a segment of a triangle. So if these represent lengths, you won't have a negative. Okay, it's a good question. All right. Now let's do this. Actually, let's grab, oopsie daisy. Let's grab a right triangle. There's one right there. Whoops. Okay. And let's scooch down a little bit. Get this out of the way. Put the right triangle right here. Make it a little bit bigger so we can work with it. Now, I could keep the right triangle like this, but you'll see a lot of times in books, they love flipping it around so it's laying on its hypotenuse. Would you agree that's the hypotenuse that's sitting on? That's close enough. Okay. Now, this is a right triangle if I put a little right angle right there. So now it's a right triangle. Now watch. We're going to use that geometric mean. That's going to come in very, very handy right here. In this particular situation. Now I know this is a pretty limited situation, but it does occur. So here's what we have. We start off with a right triangle, and then I draw an altitude from the vertex of that right angle. Hear what I just said? I draw an altitude from this vertex of the right angle. So what do? Do I go to the midpoint? Straight down? Give me a better word than that. Come on, we've been talking about this all year. Perpendicular to the opposite side. Okay, or in this case, to the hypotenuse. Very good. Everybody see that? So I've got an altitude and I've got a big right triangle. So I actually have 3 right triangles here, don't I?
Yes.
I've got this one on the left. That's a right triangle. I've got this one on the right, and I've got the whole big one. I'm not going to go through and show you all of this just for time's sake, but all 3 of these triangles are similar to each other. All right, so if they're similar to each other, the sides are in proportion. They have the same scale factor. I could, if I had time, I could split these up and show you which sides or which angles are equal to what. I could show you that the sides are proportional, which sides are corresponding to what side. But just for the sake of time, that's all done in the book if you want to look. But just for the sake of time, what I'm going to do is I'm going to show you the proportions that are made. Okay, so you don't really even have to look at them and see which one's similar to what side matches up with what. I'm just going to tell you which ones match up. Okay. Let's do this in a different color right here. Let's call this side right here, call that A. We'll call this B. We'll call this thing right here, up and down, we'll call that H for height. Is that alright? I don't want to call it A for altitude because I like to call these 2 sides A and B. And let's go with a different color right here. Let's call this little segment. Now what is that X? It's from here to where that altitude hits. Everybody see that? That's what x is. And I'm going to put a little y right here. And let's just do a different color. Watch. I'm going to label that whole entire hypotenuse. And let's label it C. Alright, so the whole thing is C. Everybody with me so far? Yeah, all I've done is just label sides of a triangle and label some segments and label the height or the altitude. Now here, there's three things, three different ratios that we want to know. See how A, H, and B are all in the same color? I did that for a reason, because these are all geometric means. Remember how I always made the geometric mean X? Well, it could be any letter, right? So A is actually a geometric mean, B is actually a geometric mean, and H is actually a geometric mean. But it's a geometric mean between what two numbers? Alright, that's what I'm going to show you right now. So, is that the color I used right there? Or was it that one? I don't know. Oh, I know what I can do. I can just click on that, and then that'll bring me to it. Yep, it's that one on the right. Okay, so watch. A is actually a geometric mean. So, how do I set up a geometric mean? Set up a ratio, and put A here and A here. Now, I tell you what. Let's do this. I changed my mind. Whoops. Let's go to this tool right here. Let's start with H. H is a little easier. I should have started with H. Let's start with H. It's the same thing, except I'm going to put an H in that place. So I set up a ratio, a proportion, and I put H here and I put H here. Now, H is the geometric mean between what other two numbers? Now, this is the new stuff right here that I'm going to show you. H is the geometric mean between the two segments of this big hypotenuse. So what are the two segments of this big hypotenuse? X and Y. So I put an X and a Y here. H is actually what we're solving for. So we'll do an example here in a second. But X and Y will just be numbers, won't they? This will be like, I don't know, 3. This will be 9 like we did before, something like that. Okay, and those will actually be numbers. H is what I'm trying to solve for. So I can actually solve for H. I can do that by cross multiplying, couldn't I? Do you see that? So if I actually knew what X and Y was, I could find what H is equal to. You with me on that? Okay. Let's do A and B now. A is also, I'll tell you what, let's put this in a box. Okay, A is also a geometric mean. Alright, so all three of these in purple right here are geometric means. You have a question?
If you knew what the measures of B and Y were, wouldn't it just be easier to do the...
Well, it depends on what they give you. Okay, I'm just setting up ratios. It doesn't matter like what's easier or whatever. There are times when you would not be able to solve for H just by knowing X and Y, just with Pythagorean theorem. So you got to know another way, and this is another way to solve for it. You're right. If I knew what A and B was, or if I knew what H and Y was, yeah, I could solve for B by Pythagorean theorem, absolutely. Okay, but there are other ways to set this up that you may not be able to use Pythagorean theorem to solve for. Okay, let's do A. A is also a geometric mean. But watch this. A is a geometric mean between the whole hypotenuse, okay, and the segment of the hypotenuse right here that's adjacent to that side A. Hear what I just said? A is a geometric mean between the whole hypotenuse. What's the whole hypotenuse?
C.
It's C. So I put a C right here. And what's the other number? It's the segment that's adjacent to side A. Which segment, X or Y, is closest to A? X is. So that X is going to go right here. Do you see that? All you got to do is memorize these. If you can memorize these, it's pretty easy. How did we get these? Did I just pull this out of the blue? No, we got it because, remember, all three of those triangles are similar to each other. And if I set up the proportions, it would eventually come down to this. I just didn't go through all the nuts and bolts to show you how we got this, okay? I just came out, I just basically am just showing you the conclusion right now. If you really want to look to see how we got to this stuff, if that bothers you, then go in the book and they'll show you how to do that. Does that make sense? All right, let's do one more. B is also a geometric mean. B and A are really closely related to each other. They're kind of like the same deal. So watch. B is the geometric mean between, what do you think? The whole hypotenuse, right? So I'm going to use this green. The whole hypotenuse and the segment that's closest to B. Which segment is closest to B? The Y is. Okay? And so I put a Y right here. reason I keep touching these is because it changes to that color, and I want to keep that color. All right. So look at it. This is to find h, right? H is the geometric mean between these two segments, x and y. A is the geometric mean between the whole hypotenuse. Do you understand what I mean by the whole hypotenuse? Because see that big triangle, that's the right angle. C is the whole hypotenuse. Okay, so A is the geometric mean between the whole hypotenuse and the segment of the hypotenuse, right? Because it's broken into two segments that's adjacent to A. I know I'm using a lot of geometry words, but you need to follow along. B is the geometric mean between what? The whole hypotenuse and the segment of the hypotenuse that's what? Adjacent or closest to side B. So it's y. So B is the geometric mean between C and y. A is the geometric mean between C and what? X. H is the geometric mean between x and y. If you can remember that pattern, you shouldn't have any problem with this at all. Let's throw some numbers in. And we can just make something up. I don't care.
90.
Well, not crazy. We're not gonna go nuts. We'll make it reasonable. Let's go small. Let's go like 7. All right, I'll just go 7. And so this one definitely looks shorter, doesn't it?
4.
It's 4. All right, 4. Let's say 4. Okay, and that's it. So what I want to do is I want to solve for A, B, and H. And if you know these two segments right there, then you should be able to solve for these three, A, B, and H. Now think about this. Before today, you would have never been able to solve for A, would you? You didn't have enough information. All you know is the length of this one hypotenuse or this one hypotenuse. You wouldn't have enough information. But if you look at your triangles and see that they're similar to each other, see the relationships, it all boils down to these three right here. So let's solve for H first. That's the easiest one. So I'm going to set up a little proportion. H is the geometric mean. So I put an H here and an H here. Between what and what? 7 and 4. So I just stick a 7 here and a 4 here. All right, let's scooch this down a little bit. So h squared is equal to, now watch, I'm not going to go 7 times 4 is 28. Yeah, I'm going to do like that. Now why did I put the 4 there first? Because I like the number I'm taking the square root of. I don't know, I just like that to go first.
What if you can take a square root from both the numbers?
Well, then you do. And that comes out to a nice whole number. Okay, that doesn't always happen like that. But if this came out to like the square root of, I don't know, could be all kinds of things. Anyway, yeah, you just take the square root of both of them. So watch, h is equal to what? What's the square root of 4? 2. And then what? Square root of 7. So that's what h is equal to. Don't write it as a decimal. Okay, guys? Don't write it as a decimal. Write it 2 square root of 7. That's how I want you to write your answer. Everybody got it? Don't write it square root of 28. Square root of 28 is not simplified. Simplify it and write 2 square root of 7. Let's do another one real quick. Look at this. Let's solve for A. So A is the geometric mean. So if it's the geometric mean, it shows up twice, right? Everybody with me on that? So the geometric mean shows up here and here. So A is the geometric mean between what and what? Between the whole thing. What's the whole thing? Give me a number. It's 11, isn't it? Because 7 and 4, right? It's the whole thing. So it's 11. So let's actually put that in there just so we can see it. All right? Let's go back to the yellow color. All right? So A is a geometric mean between the whole thing, 11, and the side that's next to A, or it's adjacent to it. What is it? It's 7. All right? So watch. This is actually even easier than this one. A squared equals. Now watch, can I take the square root of 11 or the square root of 7? No, so really the only thing I can do is say what? Actually, I was a little premature here. So 77, right? So A is equal to square root of 77. And that's all you can do. You can't simplify that any further. It's pretty easy stuff, isn't it? As long as you know the relationships. What is the geometric mean between what and what? Let's do one more. Let's find B this time. So B is the geometric mean. So I set up my proportion, B here, and then between the whole thing, what? 11, and the side or the segment that's next to B, which is 4. Okay? So we work this out. B squared equals 4 times 11. Take the square root of both sides. B equals square root of 4 is 2 square root, not 2 the, it's just 2 times the square root of 11. Or you can say 2 square root of 11. Don't say 2 the, because what does that mean? Exponent, right. So this is not an exponent. It's just 2 times the square root of 11. All right?
What if you get one that doesn't get like the square root of anything
Like this
13
one.
and 11?
This one right here.
Multiply them together.
We just did one.
Yeah.
Right here. 11 and 7. You can't take the square root of either one of them, so you just multiply them together. Okay? Make sense? I mean, sometimes it comes out even. Sometimes it comes out perfect. It might come out to like the square root of 25. But I'm not going to leave it the square root of 25. What am I going to write it as? Just 5. Okay, that's pretty easy to see. Do you agree? All right. That doesn't seem so hard, does it? No. Okay, but you got to know these. You got to know all 3 of these right here, and know that the altitude is the geometric mean between these 2 segments. A is the geometric mean between the whole thing and the side that's next to A. B is the geometric mean between the whole thing, the whole hypotenuse, and the side that's next to B. If you can remember those 3 relationships, those proportions, then you shouldn't have any problem with these. Okay? Let's do some problems so you can practice. You're not really learning unless you can do it yourself, are you? No. So here we go. It's section 8.1. Pages 535 to 537. I split it up into a couple chunks here. It's 8 to 13 and 18 to 30. There it is. Yeah, it's probably a few problems more than what you're used to, but that's all right.
Wait,
So it's 8 to 13 and 18, so you can skip 14, 15, 16, 17.
This is due Wednesday.
All right, this is due tomorrow. Good try. All right, enjoy it.